Sure.
Wonderful.
And start the recording.
Okay. Hello, all. Welcome to Microsoft Maniacs. This is not a recurring one, right? It is ad hoc schedule. Sumant come from California, and he is MVP. You guys know what does MVP mean, right? Microsoft Most Valuable Person, and he's going to talk more from.
Everyone is important here.
My God, most valuable professional. And he's going to talk more about RX and DDS today. I'll give it over to Sumant.
All right, thanks. So first of all, I want to thank Raja for accommodating me for this meetup. I asked him because I'm in Reston this week for a conference, not much of a conference, it's a technical meeting for standards. I'll talk about that little in a second. So by the way, I think that particular presenter is slightly off.
Okay. You know what, if we test that, it may go haywire. Let's not test that. People
Okay.
are good with, are you guys good with that?
Yeah, so, okay, perfect. So I thought it might be a good opportunity while I am here for the technical meeting. It might be a good chance to talk about not necessarily Microsoft technology. I mean, this was reactive extensions particularly was developed at Microsoft, but it is generally useful, and a whole bunch of languages provide now have implementation for RX. So yeah, again, thanks Raja for giving me this opportunity. I think this is the second time we are meeting here, so that's great. So today I'm going to talk about reactive stream processing, reactive programming. It's sort of the same thing for me, using DDS and RX. So how many of you have heard about RX or know RX to some extent? Okay, a couple of people here. And DDS, anyone? Okay. Yeah, that's a typical response, I know. So I'm here for a standards meeting for DDS. So DDS is a connectivity platform for Internet of Things, actually industrial Internet of Things. So you've probably heard about Nest and your washing machine talking to your fridge and whatnot. That's all consumer IoT. That's what everyone finds exciting because it's going to change your own life in your house. But much of the value sort of the industrial Internet of Things is going to come through industrial things, things like smarter cars, smarter highways, smarter airplanes, and various things. So those kind of things. So DDS is actually a technology that allows you to build really large Internet of Things, industrial Internet of Things systems. I'll touch upon it a little more later in the talk. So I have really found that DDS and RX make a lot of sense together. So by the way, how long can this talk be?
Okay. Generally, it goes from 6:30 to 7:45, 8.
7:45 up to 8. Okay, yeah, that's good. That's good. Up to 8. Yeah, I have a demonstration at the end as well. So a little bit about me. I have been doing some open source development. I have a blog, C++ tools. Most of the things on this slide are actually about C++. I'm going to talk about RX for DDS today. I don't think I'm a C# person at all. Most of my time is spent doing C++, mostly last 10 years or more. So the right-hand side stuff here, there are certain functional programming concepts here. Reactive extensions is also based on functional programming. I'm not going to go into that, but if you want to really understand reactive programming, then functional programming is going to, you will have to sort of understand, and explore that, which is pretty neat, and that's what makes it really interesting and exciting, different, and refreshing to me. So what I want to cover today is what are reactive systems? What does it really mean by constructing reactive systems or reactive programming? So when you use reactive programming, you are sort of building reactive systems. Stream processing is related, particularly relevant for DDS and when RX is put together. I will give you an overview of reactive extensions and overview of DDS. I think just bare bones, that's sufficient to understand the demo in C#. We are going to create a simple solar system based on a shapes application, sort of shapes demo. So reactive systems, right? This is something I took from the Reactive Manifesto. How many of you are familiar with Reactive Manifesto? I've heard about that. It's really about building systems that include these sort of properties. It's very responsive. You want your handheld device. That is something we are all familiar with. But many systems that are mission critical. You can think of a dam, a system, the software system that controls a dam, or air traffic control. Those systems should really be responsive. It should not wait for a flight that is landing is not going to wait for system to finish garbage collection or whatnot. Those kind of things. The systems must react to the real world at real world speed. So responsive, that's one aspect of it. Scalable or elastic. So the system should scale easily up and down based on load and CPU cores. Of course, this is sort of suggesting the cloud sort of deployment. And not all systems that I'm going to talk about are cloud-based. Resilient, yeah, that's a very important characteristic. You don't want the software system that is controlling air traffic control or a large dam to shut down while because of a segmentation fault or whatever, a Stack Overflow exception. So it has to be very resilient. It has to handle faults. Faults are going to be there, so you have to tolerate those and still continue operation. And event-driven. So why event-driven? So this is sort of all these three characteristics of systems, which are really nice to have and important, can be achieved if they are event-driven. So systems that are event-driven, generally send messages from one application to another, and they are loosely coupled. So DDS allows you to build event-driven systems. So I'm just putting Dataverse here because that's what DDS provides. But I think systems that are built on DDS are by nature event-driven, and you can achieve these other properties. The people have been achieving that for years now. It is just that Reactive Manifesto has brought together, I think, a specific style of building those applications, and that's why and new technologies for that, in Scala and other for RX, for instance. So I think this is a new term for fairly well understood way of building systems. That was a longer than I thought explanation of reactive systems. But stream processing. So this is more interesting, and you'll see some examples of this. So it's essentially an application that operates on continuous sequence of data. Data is just coming at you, and you have to do something about it. So maybe an application that looks like this. Often these reactive or stream processing systems have a sense of flow, a data flow. More than one or two, a whole bunch of streams that are coming in, and they get split into pieces. Maybe they get merged, or a whole bunch of things, and they tend to produce something at the end. And this could be distributed or in a single process. So all of these, any of these green boxes, the green circles, could be a single process, or you could think of it as distributed across machines. And of course, if it's they are different machines, then you have to have a communication technology and event-driven specifically technology that could send messages and do something. DDS does an excellent job of that. But we'll see today that you could also use RX to build your applications in this manner. And talking about one application that has, if you look into an application, sort of zoom in, you'll see sort of the same structure in sort of a data flow. Data gets in from one side, it's out from the other, and you do a whole bunch of processing in the middle. Very characteristic of stream processing. So that is related to sort of a shape of an application. If you can think of your whatever you built recently, does that application have any shape? If some sort of architecture, that's fine. But if you drill down into details, does it reveal any particular structure? Here it is more like a data flow. And data comes in here, whole bunch of things happen, maybe some things are repeated. Let's not look at this just yet. These are actually sort of some operations in RX. A whole bunch of things happen and there is an output. So you describe your application once, what needs to happen for, let's say, a particular source of data. And if there are some variants in that data, in a sense, you have, let's say, an air traffic control system and you're looking at a flight and, I don't know, Delta 1, 2, 3, 4, and sort of same things need to happen for Virgin America flight, same things sort of need to happen for other airlines. So somehow the rest of each pipeline here is taken care of automatically for you. You just described one, so your code is actually describing this, but sort of populating it multiple times or instantiating it multiple times happens automatically using RX. So this sort of parallel programming, not necessarily for performance, but that's just how the nature of the data is in these systems. Could be very useful. So this diagram actually I took from an application I built. So it may not make a whole lot of sense because that particular article describes a whole lot about each piece, and then towards the end I came up with this diagram. This is exactly how I pictured in the article or in my mind. So let me just move on. But I think you'll get a sense of data flow in the demonstration. So if all that is foreign to you, think of it in terms of Unix command line. I'm sure most of you are familiar with piping. Doing an ls or whatever, dir, and piping that through some sort of a filter, more or grep or whatever. So this is what I get on my machine, on my Linux machine. If I do a ls/ and I look for bin, I get an output bin. So what's happening here is you never really specified that. What's the meaning of this pipe? Whatever is the output of the first command, send it to the next one, it will do the right thing, it will filter it. So that's the same mindset. Only difference is that over here it happens on one line at a time. So implicitly you know that it is operating on one line at a time, and that's it. That's sort of line-oriented pipes and filter technique, and it composes, right? You can add more and more. You can grab something else. You can do awk, set. It's like a whole bunch of things. That's a really great programming model for building larger scripts with small pieces. And that same mentality we are going to use in C# programming, but the data is not going to be just a line, but in fact it could be a full structure, a full-blown structure, like a class or whatever. It can be arbitrarily big and ints, sequences, whatever. So that's the thing. And the funny thing here is perhaps so cat hyphen. So cat hyphen is essentially whatever that you type in will be sent out to grep. So if you don't type anything, it is still waiting for input. That's kind of important. It doesn't do anything. It only reacts. That's why it's sort of reactive. Only when you type in some input. And nothing happens for R, but for real, grep prints out the real that it found it. So data comes in here and gets filtered. We'll see a operator called where in RX that does exactly the same thing based on your data type. Any questions on this so far? Is it making sense? Is my pace all right, or let me know. So that brings us to reactive extensions. It was invented at Microsoft by Eric Meyer and his team, functional guru, really. So there are a lot of functional concepts, and perhaps you have heard about or you're familiar that functional programming is sort of catching on quite a bit in industry, in enterprise world. So reactive extension is a API. It's basically a library. It's for composing asynchronous streams for stream processing that we looked at briefly, and event-based programs using what is called an observable. So an observable, there is a iObservable interface in C# that represents a stream of things. Let's consider, for instance, a flight that is, say, going to land near or at the IID airport. As it comes near, the airport system sort of picks it up. So there is a life cycle for it. So the stream begins. So the system knows that this flight is coming in. It lands. It whatever takes 10-15 minutes, and it taxis, and then people get off, and the flight. So there is a life cycle for that stream, and throughout that time, it's going to send out its where its location, right? X, Y, whatever its latitude, longitude, and its height, whatever. So it's a continuous stream, and you can observe it. There are systems that are interested in its location and make sure that the two planes don't come closer than a mile in air, those kind of things. So that's an observable stream, and you can have a whole bunch of many things can be represented this way. Mouse clicks, for instance, is you can't really represent it as an array. It's really a stream of points that are just coming at you. You don't know when they come, when they show up. It's just you have to handle them when they come in. So RX lets you use observables. You can compose them together. We'll see that in code, and some sort of concurrency control over it using schedulers. The streams are first class because you get a whole bunch of iObservable objects. That's how we produce them, and you can use them. You can use lots of operators. Just like we saw in the earlier example, where filtering using grep. So that's filter. It's where in C#, strictly speaking. You can do projection, like select operation. Perhaps you're familiar with link and these operations on IEnumerable. How many of you are familiar with both IEnumerable and, okay, several of you. That's great. So you can do a lot of things with IEnumerables. Most of those are also applicable for RX for a stream that is infinite, that is potentially infinite, or at least you don't know where it's going to end. That's quite intriguing, actually, to me.
So I can see it's a bottomless list.
Mm-hmm.
And then I'm processing that using link.
Yes. Okay. Yeah, we'll see an example of that today. And that's achieved because of functional programming. Again, link is actually very much functional. And RX is available in a whole bunch of languages, modern languages usually, .NET, Java, JavaScript, C++, many more. If you want to learn more about it, there's a great presentation. So here is a link, a very recent one at a Java conference.
Question.
Sure.
Can you give us an example on where the reactive extension can be used in JavaScript? I'm just trying to understand, like you explained, when I have multiple streams of data, reactive extension is useful to accumulate together, aggregate, select, project, everything I can do.
Yes.
But with the browser, I have a UI that is only one. I have only one stream of data. So what they are using it for? Okay, so
I think in UIs, I think there is a one thread of execution, right? But number of data streams that are coming at you could be many. First of all, you could have the user input. Then, if you have made a REST call out to a web service, it could return a reply or whatever. Or if you have sent out to multiple ones at the same time, more than one could come back, and you don't know when they are going to come back. So you don't want your thread to just sit ducks over there, just waiting for this response to show up, because you want it to be responsive. So what you can do is, usually in JavaScript, people tend to write a lot of callbacks. And I'm not a JavaScript expert. I have not done much UI programming. So this is something that I have learned from presentations, really, and you can also find it out easily. That nesting of multiple callbacks becomes really heavy, and code becomes hard to understand. It's just it gets complicated. RX helps you with that structuring. It will avoid that nesting and makes it easier. In terms of number of data streams, there could be many. I mean, like I said, does that answer your question?
Yeah, thank you.
Okay.
Yeah, to add to your questions, so they have the Node.js, which is like a server-side oriented JavaScript. So maybe that would be helpful.
Okay.
Yeah, on the server
Yeah,
side.
particularly the example I gave, the presentation that I saw was about Node.js, and things get sort of unwieldy because of the callback mechanism that they use.
Yeah.
And over there also it is very useful,
Makes sense.
RxJS.
Right.
So, yeah. Okay, so main difference, let's look at IEnumerable and IEnumerator a little bit closely. In terms of sort of theory, they call it dual. So this particular presentation is a awesome presentation by, it's not a presentation, actually it's a sort of a brainstorming session between Eric and Brian. They talk about really interesting stuff about duality of push and pull. So let's look at IEnumerable, a list, right? A list is an IEnumerable, and you get an enumerator essentially that can gives you the current element, and you can move it next to the next element, and at the end essentially terminate. Because it's a list, has finite elements, you know it's going to end, you just have to wait for it, keep asking in a while. So clearly you are asking for a list each time, like, okay, give me next thing, give me next thing. It's a pull thing, right? Unless you ask, it's not going to give you much or anything. Over here, this is the IObservable or the Rx space here. You are not asking for it, it's going to send you information. So you start with a IObservable. It is something that you can look at, and it will tell you when there is an update, there is some useful information it has to tell you. You have to subscribe to it. So unless you subscribe, you are not going to get any information. You have to tell an observable that, hey, I am interested in your updates, send me those when you have them, whenever you have something to share. Okay, observable is fine with that. It will give you an iDisposable that you can just get rid of your subscription if you're not interested anymore. So that's what iDisposable is. So how do you actually get data, right? When there is data. So this is what you write, an IObserver. So when there is data, it will call onNext. It is comparable to current, to get the current one. This is the value right now. Or it could tell you, hey, I'm done, on completed. In a sense, I have no more data for you, and I'm exiting in a proper way. It's a proper good shutdown, and no more data from me, bye-bye. That's on completed. And on error is something bad happened, here is the reason, exception. So it is coming at you. This exception is not raised, it's not a thrown exception. It is actually a data object that you have access to. So you don't catch it, you just sort of just get it as an argument. The interesting thing is they are actually sort of duals of each other. So you can, anything that can be done using pull can also be done using push. In fact, if there is a list can push values at you by doing sort of onNext several times, right? And it can also tell you, I'm done, or something else is happening. Let's say if it's a database connection or whatever, it gets dropped, it could tell you that exception. So this particular discussion talks about that, how it's exactly sort of, they are equivalent. I really find that discussion very interesting. Does this difference make sense between, I think this is key to understanding reactive extensions that in some sense, it's funny the example, a mouse, right, or sequence of mouse events is an array. You could think about it. That's kind of weird way to think about it, because if they are equivalent, right, you can go from here to here or here to there, then, and you have the same operations that link has, filter, where, and projections. Those that you could do over here, they're also applicable over there. So how is it any different? You don't even know what the source of, you don't care what the source really is. Is it a mouse? Is it a list or a database or a DDS topic that we'll look at? So the programming model remains exactly the same. which is quite unusual, I think. Okay, so let's look at data distribution service. How am I doing on time? Okay. So it's a reactive middleware, and what I mean by that is, well, okay. So data, perhaps I already said this. It's a data connectivity standard for the industrial Internet of Things. So you have streaming data from sensors really fast coming at you, or events that are, if something wrong happens in a plant or or automatic assembly system or a mining facility, then those events and sensors that are producing data really fast are sent to interested applications, which could be just show me the status, what's happening, where are there alerts, is there a gas leak, or is there some excessive temperature somewhere, those kind of things. Or actuators. You could also have machines talking to machines. A sensor senses something in an assembly line, and maybe it actuates a machine down the line, something like that. So DDS allows you to do this communication, and why it's special, because at machine speeds, things don't wait. They are just going to happen no matter what. So the communication has to be a little more predictable. You cannot stop the system for garbage collection or those kind of things. And then there are various other properties like reliability and sensors. For instance, if there is a temperature sensor, oftentimes you may not care if you lose 1 or 2 sensor updates. It's coming at you really fast. Once every 1 millisecond, let's say. So it's okay if you lose one sample. If the router, the network drops one of them, that's okay. The next one is right after it. So that's not generally the case in enterprise systems, right? You don't want to lose a tweet and just forget about it, or a transaction. You want all orders, so because of that interesting characteristic, DDS offers a whole bunch of quality of services, and those quality of service are not a whole lot used in enterprise, but make a lot of sense in these sort of large embedded systems. I'm not going to go into details of it. If you're interested though, I have a couple of brochures here from my company. I work for a DDS vendor. So we are the largest DDS vendor, and our software called Connects DDS is an implementation of the standard. So
DDS is a standard?
It's a standard, yeah. Actually, several standards. There are several satellite standards around it. I'm going to talk about that briefly. So I think I already touched upon this. So the systems that are really useful, I mentioned a couple of these. It's used quite a bit in defense. There is a definition of real-time, quite interesting one. What is a real-time system that has to get job done? If there is a ship, and the ship has an anti-missile system, whatever, and there are 24 missiles at you, and if you shoot down 23, that's not real time. You have to shoot down all 24. So there is just no error, no margin for error. Sort of an interesting, I thought, example of what a real-time system is. So locomotives and factory or assembly plants. So they have to adapt to the changing environment. Things could change, fail, and there are mechanical processes or chemical processes. Because of that, things could change. Even computer things could change. Processes could fail. They cannot stop processing the information. I touched upon that. And there are real-world impulse timing. So things need to happen at machine speed, which doesn't necessarily mean it has to be like 1 millisecond or 1 microsecond or whatnot. It could be just 1 second at a time, that's fine, but it has to be done within that sort of window.
Yeah, you also mentioned about a couple times the garbage collection is it's not acceptable, but C# is run on top of CLR.
Yes.
The garbage collector could kick in any time.
Yes.
But C# is the supported language for this RX.
Yeah. So RX is not particularly about real-time systems. DDS is. My talk is about that you can combine these two things and they make a lot of sense. And I agree. We have a whole lot of C# and Java customers. So I don't want to go into the details of it. It's a bit interesting how they meet real-time requirements. Sometimes they are sort of soft requirements. They are not extremely rigid. They could handle a delay here and there every once in a while. Yeah, so in that space, it could be useful.
Okay.
Yeah. And again, a whole lot of research has taken place in garbage collection anyways, right? Generational garbage collections. I don't know, I'm not a Java expert, in fact managed expert at all. So yeah, those things could be quite relevant over here. So yeah, this is, perhaps you have heard some other real-time technologies, Java, JMS, it's really not real-time or barely soft real-time, but data distribution service could in fact span a pretty wide net. So it can handle hard real-time or even extreme real-time requirements. Web services, these two are essentially the enterprise, three actually, enterprise-oriented and not a whole lot suitable for real-time systems. Although you do see them used, so I think there is a large gray area where you could see Java and JMS used in sort of the examples of systems I showed here, these kind of systems.
Have you seen any clients use the WCF?
No.
No. COBA was like 10, 20 years ago, long time back.
It's heytime. That was actually when it was at its peak, or maybe 10 years probably.
Yeah,
it has the user base for it has reduced substantially after that. Yeah, part of it was taken by DDS and much of it by web services actually. Yeah. So here it is, sort of a few standards very quickly. So this is sort of the work I'm here for. There are several DDS spec itself that talks about how applications, the APIs, then how two DDS applications talk to each other. There is interoperability. You could have an application to larger systems like ships or the industrial IoT systems. You may have several different companies build pieces of it, and you have to have some system integrator has to use all those pieces and make sure they integrate and talk to each other. So is simplified or enabled by DDS, and it is not a easy thing to do based on what I have found over the years. So there are C++ APIs, Java APIs for DDS, and there is security standard. There is request reply, RPCO, DDS. So it's a pretty complete set of standards to build industrial IoT systems.
And there are no C# API then?
There is no standard C# API, okay. Though there is some effort, at least some interest in the standards body that I'm working for that. Yeah, we have an implementation of it, so it's not standard. Okay, so these are some concepts that will be useful for our demonstration. I think maybe about 5 minutes away from demonstration now. So in a DDS system, you want to think about a global data space. Think of it more like a database actually, although there is nothing that gets stored in disk. Everything is strictly in memory. And a global data space, you can think of multiple tables. Each table has a schema, right? And then you can read or write or whatever, do something with those, update rows, and you can look up rows using keys. So similar to that, only difference is the tables are full-blown types, like structured types, not just a flat table, but like a tree structure. And then there are domains. Domains is not really important for our discussion. It's going to be, everything is going to be done on one domain. Things in a domain just talk to each other freely, just that. A topic is very important. So a topic is essentially like a channel, a TV channel. It's something that you subscribe to, and whatever data is available, there is a publisher. The publisher doesn't know who is interested in this topic. It just says, hey, here is the state of the world as I know it. This is where I am. A flight might say, hey, this is a airplane topic or whatever, and it will say, hey, here I am, XYZ coordinates. And whoever is interested will subscribe to this topic, and they will get the notification as there are updates. So in a topic, you could talk about tracks, tracks of ships or tracks of airplanes, or a temperature sensor data. So topic will be called, it's a string, so you could call it, let's say, temperature topic. So all temperature information, let's say, is available in that topic. But then how do you distinguish between a temperature sensor that's over here and temperature sensor over there? So those sensors will have their own IDs. Those must be unique. Think of it more like a row, 2 rows in a database. They have different IDs, and you can look up based on IDs. As there are more updates from each sensor within the same topic, they are going to form independent streams of data. So now you can look at the key, and you can identify that you can actually see that, hey, yeah, I know this topic is, this particular update is for that specific sensor and not others. So topic allows you to group that together, just like a table actually, right? A table is a whole bunch of rows of different IDs, different customer IDs, if you will. And a key, just like in databases, you can identify, that's the key part, sensor ID. So subscriptions are decoupled from publications. So publishers don't know about subscribers and vice versa. Let's not go into discovery a whole lot, but it's essentially discovery allows you to, if there are a whole bunch of processes in a network, they just discover automatically each other, and they could talk to each other. So here there is a track topic that's orange, and it's talking about 3 independent tracks. You could think of it 3 different flights that are right now landing or close to an airport. And there is a different topic, let's say alarm, which is producing alarms, and these different participants in a network are interested in one or more of those things. So they don't know others exist really, you don't care, but the communication is taken care of by this. By the way, this is not a broker-based architecture. There is not a single server that is sitting and that is receiving everything and finding it out. It is strictly peer-to-peer. So actually DDS sits right here. And this is only a conceptual diagram. You don't want a broker, critical system, because what if that middle thing fails, then you are toast basically. Nothing can communicate with anything else. You definitely don't want that. Okay, so how does RX come into play? So data reader okay, RX is used for processing. This is a single process. Data is coming in through DDS from different data readers. That's what reads data from a topic, from a global data space. And a data writer writes stuff out. And like I said earlier, in stream processing, data comes in from one side and something happens to it, and some transformation or whatever, and then some other data is sent out, depending upon some processing. And we will use RX right in the middle, inside process. So the library that allows you to do that is RX for DDS. It is open source, available through this blog post. It's in C#. Next couple of slides, I don't intend to go here. This is really more for DDS. Those who are familiar with DDS, it will make a lot more sense to them. So I'm going to skip these. But the point here is a lot of concepts in DDS map nicely to RX. Okay, so we are almost there for a solar system demonstration. So a couple of things to note here. There are going to be 3 DDS topics. So this is a very simple application, particularly made for talking about the DDS concepts. So it's a shapes demo, and we are going to publish and subscribe sort of 3 topics. So you can think of square, triangle, and circle are the things that are being talked about, and you can subscribe to squares or publish squares of different colors, and we'll see what we can do with them. So a very simple example. This is the type that is being used. Like I said, in global data space, the types could be arbitrarily complex. This one is not really complex type. You could easily imagine a database table with these attributes, but it could be more complex. I'm not using it. So each shape has a color out of, say, I think 8 colors only. That's all we support. Shape size could be, this basically the shape size here. This is like 30 whatever. X and Y, that will, that's the coordinates inside. That's it. So the pieces sort of bounce around, or you can control where they belong by doing some testing processing. I think it's much better to look at the demo rather than slide here. Okay, so let's see. So I have some written here. Let's see if I could try to launch the solution. Is it making sense so far, what we are trying to do? Yeah, two different technologies, very different ones together. So I think I should comment this out. Okay, so a solar system, right? It's going to be a very simple, you don't see anything here. Wow. I think I had to pull this. How is it going to work?
I think you're extending your desktop. You want to duplicate.
So, let's search. Okay. Wow, but that's really tiny.
You can increase
The font size
font size.
from from 100% to to like 150 or 200.
That's way too big. Let's make it.
It's perfect.
It's perfect.
Mhm.
It's good. Okay, awesome. Okay, so we're going to get a solar system. So funny enough, it is we're going to have a square sun because we support only 3 topics, right? Square, circle, and a triangle. So our planets are going to be circles, a few of them, and then moon, only Earth, I mean Earth's moon is going to be a triangle. So let's see, and why that specific example? I think it's simple enough, but kind of talks about, gives the opportunity to talk about some RX capabilities and why this way. You might want to think about how you might create a solar system that things are obviously going to move around. You also wanna, okay, so in a object-oriented way of thinking, you might have an application that will create a sun, a planet, and a moon, so maybe 3 classes, and yeah, that's a pretty decent start. I wanna encourage you to think about what might be a good type for an orbit. So you have a location for planets, X and Y's, just orbiting around sun and a whole bunch of them. What might be a good type to represent an orbit? So while I'm getting ready here, let's think about that for a minute. So for an orbit, I mean, some little more information. It might be useful to think about that orbits are actually dependent on each other. For instance, well, Sun is actually revolving around the center of Milky Way, and Earth gets pulled around because of it, and of course Moon gets pulled around because of Earth. So they are not stationary, of course. So they are dependent on each other. The Earth's orbit is dependent on Sun's orbit, and Moon's orbit is dependent on Earth's, and transitively it is dependent on Sun's orbit. So you also want to capture that relationship between orbits. If you could do that, maybe that means you are using RX, but yeah, that's what we will use. And think about how you might want to do that using I don't know, good old object-oriented programming, and you actually capture this relationship between orbits. So I have a piece of paper here. I'm just pretty much going to rewrite the code I have. I just commented about, just making sure that I get it done in time. So, any thoughts on how you might want to represent an orbit?
Is it a contract? Can I see that as a contract?
Okay.
Maybe wrong.
Yeah, I find it a bit weird to think about orbit in terms of object-oriented programming, because it's sort of a it sort of yeah. Go ahead.
It's more of an emergent behavior than a...
That's right. It has sort of a behavior implicitly in it, and that's not, and it's sort of dependent on one another. It's not just a method in an object. You don't just tell orbit to, you don't just tell a planet to, hey, go orbit around or whatever. It's like it has to happen step at a time. So we'll see that actually an observable turns out to be, I think, an excellent representation for an orbit. Because, well, an orbit is sequence of points, yes, but it does not end really. Things keep orbiting around in the solar system, that's it. And it happens one step at a time, at least in this example. And we can also capture the relationship between the dependencies, the Sun's orbit, Earth's orbit, and Moon's orbit, because the eye observables are composable. You can actually tell that relationship, and you can see that in code like this. So I'm going to start with a, so this is a method that's going to, when we run this method, it's going to launch the solar system. Why does it like? Somehow it doesn't like the one.
You have to return something. You are not returning it.
But that's I'm returning iDisposable.
No, the body you are not returning yet.
Oh, I see. That's why. Oh, okay, makes sense. Okay, we'll do that in a while. So, Sun, right? Let's start with Sun directly. So, a Sun orbit. Let me just start with var, and we will change that a little later. So, directly starting with the Sun's orbit. So, what does that really mean? So, we have, okay, maybe before that, I should actually run the shapes demo a little bit here, so that you'll get a idea of the kind of shapes we are going to produce. So I'm going to publish a square, a blue square, and that's going to be our Sun. Okay, it just bounces around, and we want to build a solar system around it. So this data is being produced by this application, and our process here is going to catch that as a stream, just one stream, and that's all. And it's going to do some processing on it and produce circles and triangles, again, data flow. Those circles are again going to be shape type, and this application will again capture those. Because remember, there are 3 topics, and all these applications are familiar with those 3 topics. And if there is someone or something talking about squares and circles and triangles, this application will just pick it up and start displaying. So if I subscribe to a circle here, you're not going to see anything because there is nothing that's talking about a circle right now. and we will do that in a second. So
What is it you did just now? You subscribe to Circle?
I subscribe to a circle, but
Circle is not
there is no circle.
Right.
There is this topic exists, but there is nothing that is talking about circle. There are no updates available.
Okay.
So that's why you don't see anything. So DDS observable is the RX DDS library that is going to merge, DDS with RX, and I'm going to create a topic. I'm going to create an observable from a topic called square, but before that I have to specify the type, which is shape type, because that's the type of the topic. And so this is the default participant. This is again a DDS concept. Think of it more like a process. It's something that you need to manage all DDS entities. So that's that, and I'm going to have a square. I'm going to subscribe this because this is the sun location, right? And a scheduler. Today we don't have time to talk about it. It's essentially saying, hey, use this kind of concurrency for when you're processing this data. And you know what? This is it. This is essentially an observable. So type of this is observable of shape type. So it's essentially a stream that will produce the values of sun as long as there is a subscriber. By itself, it doesn't do anything. It only sort of creates this type, but nothing gets rolling unless there is a subscriber. So let's create that, a very simple one. And yeah, so sun orbit dot, let's just do select. So this is the fluent interface of link, essentially, dot select and dot where, those kind of things. So select, and we are going to pass in a lambda here. How do we jump over there? Shape, and let's see if we could print it. So I want to print x equal to that and y equal to that. It's really weird to type like this, but anyway, hope you can tolerate that. So shape.x comma shape.y. So okay, I need to complete that. So essentially what we just said, hey, I'm interested in values of, I think I also have to return something. So I'm just going to return shape because there is nothing else to return. So I want to select values of, I'm interested in sun's orbit, and there is a new update. Pass it as shape. So each object is going to be a shape here. And that's a lambda. Is you familiar with lambdas in C#? That's great. And I'm just printing x and y and return shape. Even with this, nothing is going to happen because we really haven't, yes, we have expressed interest, but to really get things going, we have to do something called subscribe. The reason we have to do this explicitly is because you could have a whole bunch of things between select and subscribe. You could have where, you could have all the link operators actually between here. So at the very end, you are saying, hey, subscribe. Okay, yes, I'm done with all this piping together, piping operations in a data flow, and I'm ready to go, and hence subscribe. So when you subscribe, things start rolling, and it produces a disposable, and that's your disposable. Maybe I should have this is perhaps better. How's that? Okay, let's see if it likes this code. Nope. What's going on?
Cannot be inferred from usage.
Planet location.
Subscribe is a problem.
Oh, I see. This is because I commented out some code up above. I think this function is being used in other functions, so it needs a definition of it. I will come back to that as we will make bigger. Yeah, it's up to date. That's great. Let's see what we get. So we have subscribed. So this application is going to subscribe to squares and just print them out. Let's see if it does that. So solar system. This is going to be really small. Wow, it's barely readable.
Where is that?
So properties. Is that readable?
Yes.
Anyway, so this is release solar system.exe. This is sort of a domain name. It doesn't really matter. Big Bang. Okay, that's a pretty quiet bang, but let me see what might be happening here. So that's the risk you run into when you do a live coding session.
Right.
So there is one method. I cannot think of anything. Let me start over. This.
So what are we trying to do here? We are developing some other console. Is there a console application?
Yeah, it is going to be console. Actually, you will see more interesting things in the shapes demo a little later, as we will start producing other planets.
So is it going to subscribe events from the other process?
Yes.
So I'm so curious, what's the underlying mechanism they use to communicate?
It is
Software-
essentially,
RPC?
in this case, it is shared memory.
Oh,
Because
shared
both processes are in the same machine. So
Okay.
DDS is going to use a
Named pipe? Are you using pipes?
not a pipe, a shared memory, or in some cases you can also use just UDP. Two applications in a same process.
You need to put on the network layer on.
That's a good point because yeah, let's do that.
Or you
Perhaps
don't-
maybe.
Or you guessed, only the password?
Or if I could. Yeah, it is waiting for input. Let's see that. Let's see. This is really not a good time to do debugging. Yeah, there is data coming in here. No, it's not. It's not a. Maybe. Okay, I'm going to use a different directory for this. Yeah, I should run it from here.
So the communication channel between these two processes are provided by DDS framework.
Yes. Yeah.
Okay.
That's right. Yeah, there you go. I think that was because of a configuration file in the directory I was in. That did some trick. I don't know, something else that. That's why it was not picking up. It essentially didn't finish discovery. I never specified the address or port number of the other app, right? It still figured it out because that's how DDS actually operates. It uses UDP or some other discovery mechanisms to just detect who are my friends here talking about on the same domain and what topics. It just discovers what's around it, and that's what it just did.
Question.
Yeah.
So for demo purpose, subscriber as well as publisher running the same mission.
Yes.
Generally, in a typical environment.
Oh yeah, absolutely. It's gonna be
Same mission, right?
different machines.
A different
whole bunch
machine.
of different machines.
So
Yeah.
how
Very
would that
large.
work?
It works because
What's the address of-
usually using multicast. So by default, when DDS starts, it has well-known addresses that this participant that I showed is looks at that address and sees if there is something useful information about available, and just sends information out. Hey, I am here, and let me know if you guys hear something from me. And because the other participants are also listening on the same multicast address, a specific one, a well-known one, they see, okay, seems like there is one more guy around here, and they send out, hey, okay, I'm here, and then I have these topics, I have these metadata readers and writers, and they are talking about what's everything inside the participant.
Okay, let me reshape my question, right? So did you give your multicast address as localhost somewhere in your
No.
machine?
It is just well-known. It's a well-known address that DDS standard uses. Yeah.
Okay.
You could change that.
Okay.
You can change that. You can in fact stop discovery and specify manually, because you may not want to just pick up applications just like that. There
Okay.
are,
But can
Many
this
things.
also be configurable?
yeah,
Let's say I want to deploy something in the Amazon cloud,
okay.
and then, but I want to run this in my local
That's an
machine.
interesting question. Not when if it's Amazon or over a WAN, not easily, or you have to use a little different protocols for in that case, because over WAN usually you use TCP, and for TCP you have to specify an IP address and a port. But when you are a single LAN and the kind of systems we are looking at, they tend to be large systems but closed in a sense. It's a LAN after all, and sort of more trusted. So
Okay.
it's configured for that system.
Okay.
And
Typically, right?
discounts.
Typically, IoT devices will be sitting anywhere else.
Yes.
And my observer should be sitting in the cloud somewhere.
Okay. Yeah.
So
Yeah. In that case, you need more configuration. Yeah, like a URL perhaps.
Okay.
TCP and maybe REST is probably a good way of doing it if it's a simple app.
gotcha.
You can use DDS, but then you have more configuration that you have to do to
Okay.
configure to use DDS, to use TCP and whatnot. Yeah, you could use several transports with DDS essentially. It doesn't, your application doesn't care how data ended up being there. It could be many transports, yeah, essentially that. So here it is, it's essentially, we captured it and that's it.
Sumant, would you
So
share
if
your
you
code?
leave the Discord, it's going to stop sending the message?
Yeah, that's a good question actually. So if I'm gonna hold it here. So okay, it's steady, but it's at the same location, but it's still sending updates. If I click on it, now there's hardly anything to see here. Well, okay, the app terminated actually. So let me run it again. So let me hold it. Yeah, I have clicked on it, and now it has paused publication completely. There is no more data at all. As I move it, you see there are updates. As soon as I stop moving, there are no updates. But if I release my mouse pointer, it just tells you where it is. That's all.
You will share the code, right?
Yeah,
Will you share the code?
yeah, it's gonna be online. Yeah, sure.
Okay.
Yeah. Okay, so that's that. So that's going to be our son. Okay, so I'm gonna get rid of. Well, we could just continue with printing. Why not? So, but we don't want to subscribe just yet. So I got rid of subscribe. So we are going to do a few things, and then we are going to subscribe. So let me. So from here, we want to create Earth, right? So Earth's orbit is essentially dependent on the sun's orbit. So So here's something interesting you can do. I'm gonna get rid of this part and actually do a select after this. So what I just did is right after, so sun's orbit is essentially, hey, receive this data and print it. Why not? Something like that, okay? And as long as we subscribe, it should be there. It should print and do something interesting. So for Earth orbit, right? So let's create, we are going to use pretty basic mathematical formulas for it. So there is, this is degrees, the angle for the circumference or whatever, the orbit. And because the Earth's orbit is essentially dependent on sun's, it is also a shape type. And how do we produce a stream of Earth location? By appending something, doing some processing on sun's orbit. So sun orbit dot select, not sub, sun. And each time there is a new update from sun, that's sun location. This could be also sun location. Anyway, I'm not going to change that. So when you get an update for sun location, what do I want to do? Let's move Earth by a few degrees, just one, and let's draw it at that location using some basic geometry. So this is a function that I have already written, which given 2 points, sun location has x and y, right? And some degrees, which goes from 0 onwards. Really, it keeps climbing. But we are going to use sines and cosines. I'll show you briefly that function. Pretty basic circle drawing program essentially. And let's say Earth. I have some pre-existing configuration. Earth is going to be blue in color and a certain size and those kind of things. So that, and okay. Okay, let me do this separately. So disposable equal to, did I get rid of disposable? I think I did. Okay, time to get a new one. So I'm going to subscribe to Earth now. And the funny thing is, when you subscribe to Earth, because Earth depends on sun, it is going to kickstart the whole pipeline automatically. So Earth orbit. So the particularly this piece of code is kind of important to see that you just capture the dependency directly in the code, and that Earth orbit depends on sun orbit in this way, and we'll do that by just applying this sort of transformation on the sun's location. You produce a new value. You think of it as a list. You want to filter a list and then add 5 in each integer, in each element. You might write +5, in each value, just like that actually. But the data is not there. Data will be thrown at you at a later time. So Earth orbit dot subscribe. So this is what starts everything up. But this time around, we want to see this. So what we are going to do is we are going to write the values that are produced by this observable in a circle writer, through a circle writer. This is already created. I'm not going to go into details of it. This is essentially a DDS entity that's going to write those values out and in the circle topic. And because our other application is already interested in circle, remember I subscribed to circles, but there was nothing to actually that was publishing. So it should catch the sun, the Earth locations now. Let's see if it compiles. Yeah. Okay. Here is the app. Should sort of bounce this a little, or maybe I should not. Let's just keep it here, right in the middle, and. Okay, so just square, right? There is no circle just yet, so I'm going to subscribe to it. There you go. So what just happened is, right now these values are being produced, different values. So let me change this, like let me bounce this sun a little bit.
Wow.
So you can see the values changing.
Nice.
So clearly, it's a little bit hard to see actually, because it is actually orbiting around it. If you see carefully, it's going to take some time, but it is actually orbiting.
But it's going, okay. I have one doubt. Can you move the code? Can you go to the code?
Sure.
I know that's the kind of server, who publishes topic.
Okay.
The client subscribe it and then change the server also.
Where is my mouse pointer? Sorry. Yeah, go ahead, please.
See here, the first line, right? We console our right line.
Yeah.
That is to subscribe and then display the sun's position.
Yes.
And then you are creating the Earth here, is it?
Mm-hmm.
The next one you are creating the Earth.
Mm-hmm.
Earth creation is happening at the client, at the subscription level. How it goes to the publisher level?
Okay, I see your point.
Uh-huh.
That's because of this line here. So this is now this application is not only consuming data, it's sucking in the sun location
Uh-huh.
and producing Earth locations. And that other app
Subscribes to this guy.
subscribe to it.
Okay.
So yeah, now loop is complete. That is why. So squares come in and things happen to it, circles are produced. And specifically it is written because of the circle writer. It only sends data on a circle topic. So if I subscribe for triangle, for instance, nothing will show up. But in a moment we will create moon, which will be triangle, and I think you can figure what's going to happen. So this is pretty much sort of the crux of the idea here. You just captured a rather weird type of orbit, which is sort of active. It sort of has its life, its own life, and you just sort of describe the relationship between Earth's orbit and Sun orbit. That okay, whenever you get one of those, do these things, and that's it. You never wrote any for loop here. That okay, give me some location, for loop, whatever, 10 values, do blah blah blah. You are just saying, I don't know, more like declarative. That's the sort of word here, I think. And right things happen. So this function, by the way, ends really fast. It's sort of asynchronous in a sense. It's not sitting here when you see the program, or when it runs. It in fact returns disposable and it's off in a separate loop where it's actually waiting for a keyboard input. So how is it really running, right? Because it has to come here, it has to increase the Earth degrees and produce all those things. It is happening through, if you remember, the eye observer had on next and on completed operations. When data comes in from a data reader, it triggers a chain of on next calls, one after another. First one goes to it starts with a from topic and select subscribes to this guy, and you don't see those here. If you open the implementation of select, you will find those. And on next essentially calls this, that there is data, and this one subscribes here, and then on next goes here. So it's basically a chain of things, a data flow to be precise. That's how things are executed. So this piece executes, then this piece executes for each sample that comes in. So your behavior is specified usually in lambdas.
And they are nested.
they are not nested right now. Yeah. There are cases when it becomes nested, but those are relatively advanced concepts. If we have time, we could go into it, but I think I should perhaps create Moon as well, because it's cool.
So if you create Moon, it will be a separate block. It won't be nested to the Earth.
Come again?
Like you have a Sun subscription block.
Yes.
Then Earth creation block.
Mm-hmm.
Next to that, you are going to create a Moon creation block.
Right below that. Yeah.
It won't be nested to the Earth.
No.
Okay, that's
it
nice.
is it's directly dependent on it.
Okay.
So, yeah, that's the point I want to drive here.
Okay.
So, okay. Let's just make Moon go faster, revolve faster, but of course it depends on, not on Sun's orbit, but Earth orbit. So for each, whenever I receive Earth location, increase the degrees of Moon by, let's say, 7. I found this useful constant. And draw it around Earth with these many degrees, which of course will grow every time, and use the data for Moon, which is going to be, I think, green in color. And that's Moon orbit. And remember I said, now we can just subscribe to Moon because things are dependent on each other. They will just kickstart in one shot. Well, actually there is not going to be a circle writer. So maybe I should actually subscribe to both. I take that back. So yeah, things actually do create, get kickstarted one after another as they're dependent, but we want to write Moon separately and Earth separately.
Okay.
So what I'm going to do is, I'm still going to use Earth orbiter subscribe circle writer, so we'll get Earth in the other application. And I'm also going to use, so this is perhaps, okay, now is the time to use a different return here.
Why can't you use circle letter here? I'm not clear. Why can't you use circle letter here?
Circle writer? I'll come to it in a second. Let me just finish writing this part.
Okay.
So what you can see is I need sort of multiple subscriptions, and RX provides very convenient methods to create multiple disposables when you need them, and one after another. So this guy is going to be triangle writer. I hope I've got it right. Let me just make sure. Just stop this, compile. Yeah, so the reason why we are doing this, it's nothing fancy actually. It is because we are subscribing twice, on Earth as well as Moon, and when we get those values, we are going to write those on two different channels. One is the circle channel, a topic, and another is the triangle topic. So that's why we need, at least the way it is set up, it needs, but actually you're right. I mean, I could have done slightly differently. That's something that not what I prepared today. This is how the original code looks like. Here, actually, two subscriptions simultaneously. There is going to be a Moon subscription that will activate Earth, that will activate Sun, and there is a separate subscription for Earth that is separate from all this. Those are details, I think those will come to you as you look into RX more in detail. Yeah, look and feel wise, or we could have just done select here. Why not? Maybe we could do that. Maybe after this. We could have done it just one series, but let's just go ahead with this. Does that answer your question?
Yeah, on this we'll see.
Okay.
My next question will be, why can't we always return our composite disposable? Instead of one time I'm writing circle writer,
Yeah.
another time I'm returning composite disposable. Why can't always I write composite disposable?
You could.
Okay.
You could. I mean, if you have particularly more than one subscriptions, because they are
More than one.
independent now, you want to manage them as together. So this application, when I hit enter, is going to dispose everything that was subscribed. A very simple application. So, but in a real application, you might just, well, I want to get rid of moon only. So you will just dispose this off, but keep Earth around, something like that. It gives a powerful way of managing those pipelines. In fact, very rarely do you need to use dispose actually, because what's really happening when select subscribes to Earth orbit, there is also a subscription. You don't see that because, and so back up all the way. This is the final, the top level that application produced, right? So that's why you have to manage those. But inside here, back to our sun, there are more subscriptions that are automatically managed. Okay, it's already up to date. So we don't have a triangle subscription yet. So let's subscribe a triangle. And now it is essentially orbiting around it. And of course we can bounce this.
This is nice. I'm wondering if I have to write in plain C# code without this framework, how difficult it will be and how complex the code will be.
Yeah, it will be kind of complicated. You have to probably have to maintain a whole bunch of state and know what's being done. I don't know what to think about it. And I'm pretty sure they are never going to intersect because math just doesn't allow them to intersect. You see sort of a tail here?
Tail, right.
Yeah, that tail is a special kind of DDS feature that's been shown here, which is a history. So those are old values, old 6 values. It's configurable. You can have 60, 600, 6000, whatever. If your application cares about, hey, I want to know whatever happened in last, where were you in last 10 steps, 20 steps, I want to do something about it. So DDS, okay, here it is, it's available. That's why you see the tail over there.
So are these in 64-bit?
What do you mean? 64-bit? Yeah.
Process.
I don't know. I don't know which this specifically which one this is, but yeah, you can do it in 64-bit. Yeah. Okay. Absolutely. So that is pretty much the main part of the demonstration I wanted to do, and particularly the coding part. I have written some code for a larger application, which is going to create more than one orbits, more than one planet. So I think that's 2. Okay. So this is, okay, let's keep it in the middle. So you see,
This is nice.
Venus, Mars, up to Jupiter. The slow guy is the Jupiter.
Entire solar system without silicon graphics.
So yeah, the moon is sort of going really fast.
Can you show your processor utilization, your machine?
Sure. That's gonna be
Task management?
Yeah, task management. It's barely like 1%.
So even if this
Performance?
Nice.
Nice.
So I have a question. So even if the main UI application is down, you're saying behind the scenes these are communicating. You said it's peer.
Yeah.
And then if
What do you mean by-
start open it again, and would you see them?
Yes.
There,
Yes. So for instance, we could do it now. For instance, let's get rid of this app completely. It in fact realized something happened. It discovers it that hey, my colleague just vanished, and
so if we bring that,
let's bring those back up. So let's just subscribe a triangle, and we're not going to see anything
Alright.
because sun is not there. It's like there is, remember the cat example? If there is no source, all the middle steps are just like sitting ducks anticipating some data. Nothing is there just yet. So let's publish it. And wow, don't see it. I don't know why.
Probably Reactive subscribe square first, right?
It's returning subscriptions for trial.
Yeah, it is. I don't know. It should have done that. Maybe I should start both applications. So delete all, close this. But that will kill fun out of it, right? So it's just running it. Hopefully this time it won't embarrass me. Subscribe a triangle. Don't see anything. Publish square.
Yeah.
And it's really funny to watch the moon. So this is actually how
Yeah.
moon orbits around the sun.
But
There is the Earth,
where's
but-
the Earth? Okay. Where's the Earth now?
Earth is there, but it's not been subscribed. So Earth values are there, out there in the network, but you're not showing them.
Okay.
As soon as we subscribe circles, it's going to pop up all the planets.
Hmm.
So in terms of the hosting option, right now it's a console app. Can we put this into an IIS web server, host it within the IIS?
Maybe, I don't know those details, but yeah, it's a library essentially. So DDS is a library. So if you want to deploy it in some other container or server-side
Is DDS
managed
free?
infrastructure, no, it is, well, depends. Depends on how do you want to use it.
Okay.
So DDS, no, Connect's implementation is a commercial implementation of it. So yeah, we have something called open, a version of open source that is a little bit controlled by RTI. It's not like BSD license or Apache. You can just download and do whatever with it. It is commercial in that sense.
open source.
Within, it's complicated. It is, you can share it with your friends, and then we give you a license that gives you a scope of, okay, you can share this with these companies but not outside. And mostly what happens is the systems that use DDS are very complicated and very mission critical. If something goes wrong in those systems, people die. So they are usually quite reluctant in using true open source. There are cases where people have deployed, but you really want support and someone to grab the throat off essentially when things don't work.
So, okay.
Yeah.
Let me consolidate my understanding, just validate. So with DDS, I observe things, I observe events,
Yeah.
and then I take corrective actions too, or I react to the event.
Yes. Yeah.
And then the server, the main server, observes that and changes itself. I'm just seeing practical application. If I'm launching a drone, the drone has to go from here to that area.
Mm-hmm.
But can I use this to adjust this path?
Yes, of course.
Theoretically, I should be
You are describing a perfect example, a perfect application for DDS.
Okay.
It's called it's essentially remote operator consoles. Navy and other Air Force use it quite a lot, and you have to have really fast communication. And sometimes the link is broken between your drone and your device, whatever remote control. If there is TCP connection, it will probably drop, and it's like what happens next, you don't know. DDS, because of all the QoS and everything that it brings in, can handle that extremely well. Sort of less forgiving environment. So yeah, the applications are really nice. But that's an excellent point, and those systems really exist today, where underwater submarine, unmanned submersibles or proper UAVs, yeah, they are controlled today. Just the final one, I think you kind of enjoyed looking at this demo. That's why, what might happen if we produce another sun?
Chaos.
If we had two suns, what might look or find in the sky, right over here at least. So let's launch that. So, well, so far just one sun, right? And it's doing its thing. And let me see if I can publish another square of a different color. So this is going back to the the database rows. Another sun is a distinct sun of a different color, and color being its key. It's orange sun. That's it. There's actually another solar system, entire solar system for you. So what just happened is the code is slightly different from before. There is some nested stuff going on here because now you have to be aware of, hey, there might be two suns, not just one sun, and because there are two things in a topic, maybe 3, 4, 5. I mean, if you add more suns, there will be just more solar systems just like that. But it essentially replicated. Remember, I talked about the shape of an application. It just replicated the whole pipeline yet another time for a different sun. You just described once, and it produced it one more instance of it, and it will just produce it. So here is interesting part. So I also said about a life cycle. So if I delete the first sun, it takes away the solar system with it. So here is the first sun, this first square, and I'm gonna dispose it off, and the whole solar system. So anything that was dependent on it,
Takes up.
it's gone. So that's very data centric. That's the term. I know in DDS you'll find that quite a bit. Things that are dependent on on the source or whatever, this data object, that dependency is managed really nicely now. You didn't write code for managing those separately. You really should have to look at the code because it's slightly different. So it's not exactly the same. But I think it simplifies things quite a bit and makes programming simple. Yeah.
So can you relate DDS with SQL Server Stream Insight?
Okay, what's that?
Okay.
Well, if
Stream
it's
Insight handles this kind of stuff.
okay,
They say, I've not explored it yet, but I've just read about it. It processes multiple streams of data, and then you can make meaning out of it. But yours looks like you're taking some actions also based on that.
yeah,
Whereas Stream Insight, it just provides information.
okay.
I thought you would know about it. Okay, it's okay.
Okay, it's more like TDS in that sense. It provides information and you can send information. But combined with RX and DDS evolved completely independently, right? And DDS has been around for 10, 11 years now. RX is probably last 4 years, maybe,
Okay.
maybe a little more, 6 years, 2009. So, but they make sense together. That's my point.
So if I want, I can implement the same application using RX without using DDS.
Which application?
This same kind of application.
Yes.
Would I be able to do that?
Well, that depends, Are you also talking about discovery? Well, then you will end up doing the same thing that DDS does.
Discovery means endpoint discovery?
Endpoint discovery.
Okay, without that.
Okay.
Okay.
If you are using history, well, you end up using
DDS.
creating things that DDS does. So my point being, yeah, exact application is perhaps, it's just like DDS. But yeah, more or less you could create this. Yeah, or JMS. Yeah, you can have this, I guess, more or less.
Thank you.
Yeah.
Yeah, just one question for you. So one of the main things I wanted to figure out here, have you used TPL at all? And if so, how would you kind of contrast this versus TPL? Because like, let's say I built a TPL app. Basically, I could build it functionally where a particular stream buffer comes in or just an input and basically just chain a bunch of tasks to make a pipeline. So how would that kind of contrast with building it sort of reactive style?
Yeah, I think the TPL app, I would call it reactive actually, because again, you do create sort of a data flow and dependencies in it of data flow, and you create sort of this graph. I think the main difference between TPL and here is the stages that you created are created just once and for all, or strictly throughout the life cycle of the stream. But in case of TPL, you will have to create those tasks or futures in some other languages, C++ particularly, each time that you send out a request, you produce a task, and those tasks have dependencies. As soon as one response comes back, because it is ready to handle exactly one response, it will go through the data flow just like this, and it will take away the entire chaining of operators. Now next time around, you have to create the chain all over again. It's exactly the same code, and you will take it away again. So you will produce these objects over and over again. You will produce the same data flow over and over again using TPL. I think that's, to the extent I know about it, that's what will happen. But here, you create the pipeline once. Everything that happens before subscribe is just done once, and you just at the end say, hey, launch this, subscribe, and then the pipeline does not go away till either there is an error, or on completed. So on completed, one way or the other it has to finish, until then it will survive. So there is less of overhead, I think. But I think both are reactive. Does that answer your question?
Yeah, I just kind of want to get a feel. I mean, seems valid as any answer that essentially, when you get to the low level, maybe one takes more memory versus
TPL
more
is
allocations.
Little more low level, but at the same time, that's why it gives more control.
TPL, you mean task availability?
Yeah,
Yeah.
so basically, you can use TPL data flow too, which kind of has built-in stuff for like buffering and blocks, but like just TPL, just tasks basically. So just passing tasks around and making a pipeline. Right.
Yeah, I'm done. I mean, yeah.
Thank you.
Great questions.
Thanks a lot. We will meet the next session. Next month, April 25th.